Today I want to answer a simple question. How does a machine know when two things are similar? Not by feeling, by math. Specifically, one elegant idea called Cosine similarity. By end of this, you will understand why direction matters more than size, and why that one idea quietly powers search engines, recommendation system, and even how language model works. Let's start with three people: Gorky, Marx, and Che. Gorky and Marx are calm, composed, easygoing. Che is intense, bold, reacts very fast. Without any math at all, you would instinctively say Gorky and Marx are similar. Che is different. That's completely human judgment, no computation involved. So, here is the real question: how would a machine reach that same conclusion? The first step is this: everything can be turned into numbers. Let's score each person on two traits: aggressiveness and calmness. Gorky is 2 and 8, Marx is 1 and 7, Che is 8 and -2, intense and not at all calm. Now plot these points in space, what we call vectors. Look at the graph. Gorky and Marx land right next to each other. Che sits apart below the axis, and as we will see in a moment, at an exact right angle to Gorky, we didn't need to feel anything, the numbers did the work. This is the foundation of how machines understand anything. Turn it into a vector, plot it, and now you can do a math on it. But how do we actually measure how close two vectors are? The first tool machines reach for is the dot product. It's simple: multiply the matching numbers from two vectors, then add them up. Let's try Gorky and Marx. 2 times 1 plus 8 times 7, that's 58, a high positive number, which tells us these two vectors point in nearly the same direction. Here is the cheat sheet. A high positive number means similar, 0 means the vectors are perpendicular, completely unrelated, and a negative number means they point in a opposite direction. In fact, Gorky and Che come out to 0. They are at 90-degree angle. And Marx and Che come out negative, pointing in opposite direction. So far, this matches our intuition perfectly. But here is the catch. Let me introduce the fourth person, Liya. Her vector points in the exact same direction as Gorky's. Same personality profile, just smaller in magnitude. Look at the diagram on the right. See the dashed line. Gorky and Liya sit right on it, same direction, just different length. Now watch what happens with the dot product. Gorky's dot product with Marx equals 58. Liya's with Marx equals to 50.8. Based on those numbers, it looked like Gorky is more similar to Marx than Liya. But that's wrong. Liya and Gorky points in exact same direction. The angle between each of them and Marx is identical. So why are the numbers different? Because the dot product is squared by magnitude, vector length, not just direction. We need a tool that removes size from the equation entirely. That tool is cosine similarity. Here is the idea: take the dot product and divide it by the length, the magnitude of each vector. This formula strips away size completely. What's left out is pure direction. Let's run these numbers again. Gorky and Liya, cosine similarity of 1.0, perfectly aligned, which makes sense since they point the same way. Gorky and Marx about 0.995, and now Liya and Marx about 0.994, nearly identical. There it is. The numbers now correctly show that Gorky and Liya are nearly equal, close to Marx, because cosine similarity only cares about direction, not size. So how do you read cosine similarity score? It's simple: scale from -1 to +1. +1 means the vector point in exactly the same direction, i.e. similarity. 0 means they are perpendicular, no relationship at all. -1 means they point in completely opposite direction, total contradiction. Going back to our example, Gorky and Marx come out around 0.995, highly similar. Gorky and Che come out at exactly 0, unrelated, and Marx and Che come out slightly negative, a mild, not a strong opposition. This one idea, comparing direction instead of size, is quietly running behind technology you use every single day. Search engines use it to rank pages by how closely their meaning aligns with your query, not just keyword overlap. Recommendation system use it to suggest songs, shows, or products whose vector point in a similar direction to what you already like. And language models use it constantly to judge which words and concepts are related in meaning, which is part of what lets them generate coherent context-aware text. Let's bring it all together in 4 steps. 1. Turn everything people, text, songs into a vector of numbers. The second, the dot product gives a rough similarity signal, but it's skewed by vector size. Third, cosine similarity removes magnitude and measures only the angle between vectors. Fourth, the score from -1 to +1 tells us exactly how aligned two things really are. And if I have to boil this whole talk down to one sentence, it's not about how much, it's about which way. So the next time a search engine or a recommendation algorithm seems to just know what you are looking for, remember, there is no magic there, just vectors, angles, and a simple bit of math. Thank you.